uh, structures, no, and functions, no. So okay, so in programming, structures refers to a way of grouping related data items together under a single name, no, known as a struct, no. And this allows for the creation of more complex data types and can make code easier to read and maintain. Let's say, for example, no, yung struct command, no, or struct may be used to group together information about a person, such as their name, age, and address. So functions, on the other hand, no, refers to a block of code that performs a specific task or set of tasks. Functions are used to break down large programs into smaller or more manageable parts, making it easier to develop and maintain code. So function can also be reused in different parts of a program or in a different programs together. In our field of IT, no, structure and functions often work together, no, to create more complex systems. Let's say, for example, a program, no, or let's say, for example, no, a program may use a struct, no, to represent a data structure, and then use function to manipulate that data struct in various ways, no? And this can help to make programs more modular and easier to understand, as well as more efficient and maintainable. Okay, so in design, no, structured refers to the way that visual elements are organized within a design to create a cohesive and balanced composition. And this includes considerations such as the arrangement of elements on the page and the use of grids and other layout tools, and the use of color, typography, and other design elements, a hierarchy of information. So I just want to play a series of video which we can help you to understand more about, of course, the structures and functions under data structure and algorithm. Okay. So as you can see, no, most of our discussions is focused on an advanced one, no? It's maybe an
Understanding the topics like linked list, tags, queues, etc. We should understand the relationship between structures. That is why
We have devoted several lectures on structures and functions, and this is part 1 of structures and functions. So let's get started. Here is a quick recap of what a structure is all about. A structure is a user-defined data type that can be used to group elements of different types into a single type. We have already learned what a structure is in our C programming lectures. Here, I'm giving you a quick recap of what a structure is all about. A structure is a user-defined data type. First of all, it is defined by user, and here it is used to group elements of different types into a single type. For example, here you can see that I have declared a type struct student. What I am doing here is I am combining all these different types into a single type. This is the type created by me, struct student, and here I am combining all these types into a single type. These are the topics we will cover in this lecture and the subsequent lectures. The first topic of our concentration will be passing structure member as argument. Then we will understand how to pass structure variable as argument, and we should also understand how to pass pointers to structures as arguments. Then we will understand how to return a structure variable from the function, how to return a pointer to structure from the function, how to pass array of structures as arguments, and finally, we will understand what are self-referential structures. So the topic of our concern for this lecture is passing structure member as argument. So let's get started. How to pass structure members as arguments? Just like variables, we can pass structure members as arguments to a function without any problem. Just like variables, there is no difference. We can also pass structure members as arguments to a function. For example, here I am considering this structure, which we have already seen. This struct student consists of 4 different types. One is the name of the student, the other one is the age, and then the roll number, and finally the marks of the student. Now, I want to shift your attention towards this main function. Here you can see I have declared a variable of type struct student, and by using this variable I am initializing these members. You can see the name has been initialized with Nick, age has been initialized with 16, roll number is 50, and marks obtained are 72.5. So this is the data of the student Nick, who has scored 72.5 marks, his age is 16, and his roll number is 50. Now, I am using this print function to print all this data on the screen. Here you can see the declaration of the print function. It consists of these 4 parameters. Obviously, they will receive the values which I am passing over here. Here you can see I am passing the s1.name, then s1.age, s1.roll number, and s1.marks. These parameters will receive them in this order, right? This printf function will print all the values of the members on the screen. Here you can see the first name will get printed, then age, then roll number, and then finally marks. Now let's execute this program in our favorite IDE. Let's execute this code. You can see the output is Nick 16, 50, 72.50. Why I'm getting 72.50 over here? Because I put here %.2f, which means I want precision up to 2 decimals. That is why it is giving me the precision up to 2 decimals. The result is 72.50. You can see the name, age, roll number, and marks all are printed on the screen. It is not the case that we can only pass the values of the members. We can also pass their addresses. Instead of passing the copies of the structure members, we can pass their addresses or references. Here is an example. You can see over here that I have declared a different structure. Here I have named it char set. Now, this is an interesting structure. It consists of 2 members. One is the character variable and the other one is an integer variable. What I want to do here is I want to create my own character set. We are aware about one character set, that is ASCII character set, that is American Standard Code for Information Interchange. This character set consists of several characters as well as their associated codes. We know that character capital A has an associated code 65, right? Similarly, I want to create my own character set. So I have created this char set structure which consists of these 2 members. Now here you can see the main function I have declared. Within this main function, I have created a variable of type char set, and what I want to pass the addresses of these members to this key value function. And here is the declaration of this key value function. This key value function consists of 2 parameters. The one is the pointer to a character and the other one is pointer to an integer. And here you can see I'm passing the addresses of these members, right? I'm passing the address of this first member S and the second member I. And these are received by these pointers. Now here you might be wondering why I haven't put any brackets over here to indicate that this has to be evaluated first and then after that this has to be evaluated. You should understand that dot operator has greater precedence than ampersand operator. That is why there is no need to put brackets over here. Instead, this will automatically get evaluated. cs.s will get evaluated first and then after that ampersand will get evaluated. So it is clear that first the members has been accessed, then after that with the help of ampersand operator we will receive their addresses. We are passing these addresses to this key value function and here these pointers will receive the addresses. And then what I'm doing here is I'm using scanf function to ask user to enter the key value pair. Here key means the letter and the value means the associated code of that letter. Okay. So the first argument must be the character and the second argument must be the code associated with that character. Maybe the user will enter the character capital A and he wants to enter the value 1 as the code for that character. So he must have to specify A space 1. Okay. Scanf function will receive those inputs and it will get reflected over here, right? Obviously, the variable which I have created is local to this main function. The members of this variable will receive the values entered by the user, and then with the help of printf function, I can print those values on the screen. Let's execute this code in order to see the results. Here I have entered the letter A as well as the code associated with it, which is 1. You can see over here, the letter A and code associated with this will get printed on the screen. That is what I want, right? Here, this is just a simple program where I'm just printing the character as well as the code associated with it. Just one character and one code, right? We can modify this code to create different character sets, and if we want, we can print them all on the screen, or we can use them according to our needs. Okay friends, this is it for now. Thank you for watching this presentation.
Okay, so as our video mentioned, no, in programming, no, it is common to pass structure membership as arguments to functions. And this allows the function to access and manipulate specific members of a structure without needing access to the entire structure itself. So, to pass a structure member as an argument, you need to first declare the functions to that member as a parameter. Let's say, for example, as what our video presentation mentioned earlier, no? Suppose you have a structure called person with member's name and age. So, you could write a function that takes the name member as an argument. Like for example, void print underscore name, open and close parenthesis car asterisk, no, then name or close parenthesis begin. Then print open parenthesis double quotation name colon ampersand percent s of course for string slash backslash n double quotation comma the name then semicolon then end. No, so then calls to these functions with the name member of a person structure. So you would simply pass the name member as an argument, like struct space person space my underscore person is equal to yung curly bracket, no? Let's say double quotation Marmelo Abante double quotation comma 30. Then yung ating curly bracket na close, then semicolon. Then print underscore name open parenthesis my underscore person that name close parenthesis semicolon. In this example, the print underscore name function takes a single argument which is a pointer, no, to a string containing the name of the person. So when we call the function, we will pass the name member of the my underscore person structure as the argument. So passing structure members as arguments can be useful in a variety of situations, such as when you only need, no, to manipulate a specific member of a structure, or when you want to pass data between functions without exposing the entire structure. Now, based on the given outline earlier, no, we are going to have a discussions about passing structure variable as argument. In programming, especially in data structure, no, passing a structure variable as an argument to function is a common way to provide the functions with access to the data contained within the structure. And this is often used when a function's needs to manipulate or perform operations on the structure's data. So, to pass a structure variable as an argument, you simply include the variable name in the function, on the function call. Let's say, for example, struct, no, space, my underscore struct, then yung ating begin, no, int x as our data types and variable, then semicolon, int y, semicolon, that's also another variable, then end, semicolon. Then void, space my underscore function, close parenthesis, no, then struct space my underscore struct, then s as our new variable, then close parenthesis, then begin. So s dot x is equal to 5, s dot y is equal to 10 semicolon, both semicolon, s dot x is equal to 5 semicolon, s dot y is equal to 10 semicolon. Then print open parenthesis, yung double quotation natin, the x colon, then tapos %d, comma, then y colon, %d backslash n, double quotation, begin. Tapos tatawagin natin si s, x, then s dot x at saka s dot y, close parenthesis semicolon, then n. Then right after that, we're going to have an int main opening close parenthesis, then begin. Then struct, no? My space my underscore struct S is equal to yung ating curly bracket 0, 0, then close yung bracket, then semicolon. So my underscore functions, open in close parenthesis sa S and semicolon. Then we're going to print, no, double quotation X colon %D, comma, then Y, yung ating dot, ano, then %D \n, double quotation, comma, then tawagin ulit natin si S dot X, comma, S dot Y, close pa semicolon, then return space equal to 0, then semicolon, then end. In this example, we define a structure called my underscore struct with two integers variable, that is X and Y. Okay. We then define a function called my underscore function, and that takes a single argument to type, or single argument of type my underscore struct inside the functions. And we modify the value of S dot X and S dot Y, and then print out the new values. So in the main function, we declare a variable of type my underscore struct called S and initialize it with zeros. So for both members, so we then call the my underscore function with S as the argument. So after the function call, we print out the values S dot X and S dot Y again to see if they have been modified by the function. So passing a structure variable as an argument can be useful when you need to perform operations on the entire structure, or when you need to modify the structure's data within the function. However, it is important not to note that passing a structure variables as an argument create a copy of the structure, so any changes made to the structure inside the functions will not be reflected in the original structure. I just want to show you a presentation, no? A video presentation again of a demonstration of what I have mentioned earlier about the structure. Passing structure variable as an argument. Okay.
Let's discuss part 2 of structures and functions. In this presentation, we have covered
This topic, passing structure member as argument. Now in this presentation, we will discuss passing structure variable as argument. So let's get started. Instead of passing structure members individually, it is a good practice to pass a structure variable as an argument. Why you are simply passing structure members individually when you can pass a structure variable as an argument and then decode it in the other function? Unlike arrays, name of the structure variables are not pointers, let me tell you. When you are passing the name of the array, actually you are passing the address of the first block of the array. But when you are passing the name of the structure variable, actually you are passing the value or copy of that variable. So name of the structure variables are not pointers. Actually what you're doing, you are passing by value and not by reference. Now here is an example which helps you to understand how to pass a structure variable as an argument. Let's discuss part 3 of structures and functions. In the previous presentation, we have learned how to pass structure variable as argument. Now in this presentation, we will learn how to pass pointer to structure. Let's discuss part 2 of structures and functions. In the previous presentation, we have covered this topic, passing structure member as argument. Now in this presentation, we will discuss passing structure variable as argument. So let's get started. Instead of passing structure members individually, it is a good practice to pass a structure variable as an argument. Why you are simply passing structure members individually when you can pass a structure variable as an argument and then decode it in the other function? Unlike arrays, name of the structure variables are not pointers, let me tell you. When you are passing the name of the array, actually you are passing the address of the first block of the array. But when you are passing the name of the structure variable, actually you are passing the value or copy of that variable. So name of the structure variables are not pointers. Actually what you're doing, you are passing by value and not by reference. Now here is an example which helps you to understand how to pass a structure variable as an argument. Here in this case, I have declared two structure variables P1 and P2. These two variables are initializing these variables over here. You can see the struct point declaration. This struct point has two members, X and Y, both are of same type. This P1 variable is initializing these two members in this way, that is, X has been initialized by 23 and Y has been initialized by 45. Similarly, P2 is also initializing these variables with these values, that is 56 and 90. X will receive value 56 and Y will receive value 90. Then we are calling the print function and we are passing p1 as an argument, which means that we are passing the whole variable and not the individual members. Here you can see that we are not passing p1.x and p1.y, we are passing the whole variable. When you're passing a variable, it is a call by value and not call by reference. So here the copy will be passed, and you can see over here there is a variable available, which is the parameter of this function.
Sir,
It will
excuse
receive
me, sir.
the copy of p1, and within this function we can see we have a printf function
Sir?
which will print all the member values associated with this p1 variable on the screen. And then after that we are calling this print function again, and this time we are passing p2 variable. Now it is not difficult to understand that this printf function will print the member values associated with this variable on the screen. So the output of this program is 23, 45,
Sir, walang
56,
nag-reply po.
90. You can
Sa
understand
screen.
that I'm not passing the individual members,
No,
I'm
sir.
passing the
Wala po
whole
nag-replay,
copy of a
sir.
variable, and this is always a good
Kamsahamnida.
practice. So from now on, you should try to pass variables and not the individual members. Okay friends, this is it for now. Thank you for watching this presentation.
No, sir.
Thank you, Fred.
Of structures and functions. In the previous presentation, we have covered this topic, passing structure member as argument. Now in this presentation, we will discuss passing structure variable as argument. So let's get started. Instead of passing structure members individually, it is a good practice to pass a structure variable as an argument. Why you are simply passing structure members individually when you can pass a structure variable as an argument and then decode it in the other function? Unlike arrays, name of the structure variables are not pointers, let me tell you. When you are passing the name of the array, actually you are passing the address of the first block of the array. But when you are passing the name of the structure variable, actually you are passing the value or copy of that variable. So name of the structure variables are not pointers. Actually what you're doing, you are passing by value and not by reference. Now here is an example which helps you to understand how to pass a structure variable as an argument. Here in this case, I have declared two structure variables p1 and p2. These two variables are initializing these variables over here. You can see the struct point declaration. This struct point has two members, x and y, both are of same type. This p1 variable is initializing these two members in this way, that is, x has been initialized by 23 and y has been initialized by 45. Similarly, p2 is also initializing these variables with these values, that is 56 and 90. X will receive value 56 and y will receive value 90. Then we are calling the print function and we are passing p1 as an argument, which means that we are passing the whole variable and not the individual members. Here you can see that we are not passing p1.x and p1.y, we are passing the whole variable. When you're passing a variable, it is a call by value and not call by reference. So here the copy will be passed, and you can see over here there is a variable available, which is the parameter of this function. It will receive the copy of p1, and within this function we can see we have a printf function which will print all the member values associated with this p1 variable on the screen. And then after that we are calling this print function again, and this time we are passing p2 variable. Now it is not difficult to understand that this printf function will print the member values associated with this variable on the screen. So the output of this program is 23, 45, 56, 90. You can understand that I'm not passing the individual members, I'm passing the whole copy of a variable, and this is always a good practice. So from now on, you should try to pass variables and not the individual members. Okay friends, this is it for now.
Okay. So to continue, no? Next in line actually is the passing pointers to a structural arguments. No? Passing a pointer to a structure as an argument to a function is a common way to provide the function with access to the data contained within the functions and the structures. This method is often used when you want to modify the data in the structure, as it allows you to directly manipulate the original data rather than creating a copy of the structure. So, to pass a pointer to a structure as an argument, you first declare the functions to take a pointer to the structure as a parameter. Let's say, for example, struct space person, yung ating open, yung begin, no? Car as our data types, then space name. Then kung array siya, lagyan natin ng brace yun. no? Then tapos 50, no? Yun ang pinaka-array value natin, semicolon. Then int, another data type, then age as our variable, then semicolon, then end, then semicolon. We can declare a function, no, that takes a pointer to a person structure, no? Halimbawa, void space modify underscore person, open parenthesis struct space person asterisk space p close parenthesis then begin p minus greater than age is equal to 30 close parenthesis then end. In this example, no, the modify underscore person functions takes a pointer to a person structure as its parameter. The functions, no, then modifies the age member of the structure using the arrow operator, yung ating greater than value, no? To call the functions with a person structure, we simply pass pointer to the structure as the argument. Halimbawa, struct space person, my underscore person is equal to, yung syempre kung mag-a-array tayo, no, yung open bracket natin, no, curly bracket, curly bracket, double quotation, halimbawa, Marmelo Abante, double quotation, comma, 25, yung close na curly bracket, din semicolon, di ba? Then modify underscore person, open parenthesis, yung ating ampersand, that's our pointer, then my underscore person, close parenthesis, semicolon. In this situation, we create a person structure called my underscore person, and we initialize its name and age members. So we then call the modify underscore person function, passing in a pointer to my underscore person using the address operator, yung ating ampersand na sinasabi ko kanina. Okay? So, another video presentation para mas magkaintindihan tayo.
Let's discuss part 3 of
structures and functions. In the previous presentation, we have learned how to pass structure variable as argument. Now in this presentation, we will learn how to pass pointer to structure as argument. So let's get started. If the size of the structure is very large, then passing the copy of the whole structure is not at all efficient. Let me tell you that if the size of the structure is very large, then it is not a good practice to pass the whole copy of the structure. The better choice is obviously to pass the address of the structure. You can use the arrow operator to access the structure members inside the called function. In the called function, you can use this arrow operator to access the structure members. And here's how you can do that. I'm considering here the example where I'm passing the addresses of P1 and P2 to this print function one by one, and then I will access the members within this print function using the pointer. Here you can see I have declared P1 variable of type struct point. This P1 variable is initializing the members, that is X and Y, with these values, that is 23 and 45. Similarly, P2 variable is also initializing these members with these values, that is 56 and 90. With the first print call, I am passing the address of P1. You can clearly see over here, I am passing the address of P1. And in the second print call, I am passing the address of P2. So basically, I am passing these addresses one by one. These addresses will be received by pointer one by one, right? First, the address of P1 is received by the pointer. This pointer contains the address of P1. Here in this printf function, we are calling the members associated with P1 variable using this arrow operator because PTR contains the address of P1 initially. So it is the case that we are accessing the member value associated with P1. Obviously, this member is X. So we are asking for the value of X, which is initialized by P1, right? And similarly here, we are asking the value of Y, which is initialized by P1. These values will get printed on the screen using printf function. And then after that, we are calling this print function again. But here in this time, we are passing the address of P2 and not the address of P1. So obviously, we are asking the values of X and Y initialized by P2, right? So the output of this program is 23, 45, 56, 90. Here in this case, obviously, we are passing the addresses and not the copies of the variables. So it should be understood that this practice is good in the case when the structure is very large in size. Okay friends, this is it for now. Thank you for watching this.
Okay. So again, as I mentioned earlier, no, returning a structure variable from a function is useful when you want to modify the data in the structure within the functions and return it to the calling functions for a further use. So it can also be more efficient than passing a pointer to a structure as an argument, as it avoids the overhead of managing a pointer. The next topic that we're going to discuss is returning a pointer to a structure from the functions. Because returning a pointer to a structure from a function is another common technique in programming. So this method is often used when you want to create a new structure within a function and return a pointer to it, or when you want to modify the contents of a structure within a function and return a pointer to the modified structure. So, to return a pointer to a structure from a function, you first declare the function to return a pointer to the appropriate structure type. Let's say, for example, struct space person, curly bracket or open or begin, no, car, then name, then tapos yung brace, no, na 50, ang ating target na text is 50, then close bracket, then semicolon, then int as our new variable, no, then data type, sorry, then age as our variable, then semicolon, then end natin yung curly bracket natin, ano, then semicolon. Then we can declare a functions that return as a pointer to a person structure, katulad ng struct space person underscore get underscore person, open parenthesis void, close parenthesis begin. Then struct space person, asterisk p is equal to malloc, yung pinag-aralan natin last time, close parenthesis size of, open parenthesis struct space person, dalawang close parenthesis because we have an open size of open struct, not in semicolon. Str copy, that is string copy, shortcut for string copy, open parenthesis p, yung arrow na pinakita natin kanina, name, comma, then let's say Marmelo Abante, naka-double quotation, close for semicolon, then p, yung arrow, no, age is equal to 25, semicolon, then return p, semicolon, n. In the mentioned example, the get underscore person functions return a pointer to a person structure. And the function creates a new person structure dynamically using malloc, no, the reserve word, and initialize its name in age members. So the function then returns a pointer to the newly created person structure. So to use the return pointer, no, to the person structure in the calling function, we can assign it to a pointer to a person structure, a variable. Halimbawa, struct space person asterisk, siyempre yung asterisk yun yung ating pointer, no, asterisk my underscore person is equal to get underscore person open close para semicolon. So in this example, we call the get underscore person functions and assign the return pointer to a person structure variable called my underscore person. Okay, I just want to show you another discussions, no, of what I have mentioned about returning a pointer to a structure from a functions.
Let's discuss part 4 of structures
and functions. In the previous presentation, we have discussed how to pass pointer to structure as argument. Now in this presentation, we will learn how to return a structure variable from the function. So let's get started. Returning a structure variable from a function is similar to returning a variable from a function. Returning a structure variable from a function is equivalent to returning a normal variable from a function. It is as simple as that. Now here let's consider one example which helps us to understand how to return a structure variable from a function and how it looks like. Here in this case, you can see in this main function, I have declared these two variables p1 and p2. p1 is initializing these members, that is x and y, with these values, that is 23 and 45. p2 is initializing these members with these values, that is 56 and 90. Why is that so? p1 is of type struct point, and you can see the type here. It consists of two members, x and y. And here you are just initializing these x and y variables, right? Now we are calling this edit function, and in the first edit call, we are passing the copy of p1 variable. You can see over here that I'm just passing the copy of p1, which is obviously received by this p. This p variable is of type struct point. Obviously it has to be, because here we are passing p1 variable which is of type struct point. The data type of parameter and argument must match. That is why this type must be struct point. Here p contains the copy of p1, which means that the values associated with p.x and p.y is equivalent to the values of p1.x and p1.y. This means that p.x contains 23 and p.y contains 45. Here in this case, we are incrementing p.x by 1, which means that 23 has been incremented, which gives the value 24, and it will get stored within that p.x only, because p.x plus plus means p.x equal to p.x plus 1. So the changes will get reflected in p.x as well. Similarly, we are making changes here in p.y as well. We are adding 5 to p.y, which means we are adding 5 to 45. It gives 50, and p.y in this case contains 50. After that, we are returning p. And here you can see the return type is struct point. Obviously, it should be struct point because p variable is of type struct point. Here, the p1 variable will receive the changes made by this p variable. So p1.x is also updated by 24 and p1.y is updated by 50. Now, we are again calling this edit function, and this time we are passing the copy of p2. Again, the changes made over here will get reflected over here, which means after this call, 56 becomes 57 and 90 becomes 95. After that, we are calling print function. First, we will print the values associated with p1, that is the member values of x and y associated with p1, and then we will print the member values associated with p2. You can see over here the definition of print function. It just contains printf function, which will print the member values associated with these variables. So the output of this program is 24, 50 and 57, 95. You must be careful about the types, okay? The parameter type and the argument type must match, and because here you're returning the variable of type struct point, so the return type must be struct point. Okay friends, this is it for now. Thank you for watching this presentation.
Okay, so again, as I mentioned, no, returning a structure variable from a function in a common way to provide the calling functions with access to the data contained within the structure. And this method is often used when you want to modify the data in the structure within the function and return it to the calling functions for further use. So this time, wait.
Let's discuss structure.
Functions Part 5. In the previous presentation, we have learned how to return a structure variable from the function. Now in this presentation, we will learn how to return a pointer to a structure from the function. Here, we are directly considering the program. I want you to understand this program very carefully, okay? There are certain points which we need to understand in this program. Here you can see we have to start with the main function, just act like a compiler. So we know that compiler starts from the main function, no matter what the code has been written. So let's start with the main function. Within this main function, you can clearly see I have declared two pointers, ptr1 and ptr2. You can see over here, their types are struct point. That means they will point to a struct point type of data, right? So PTR1 will point to data of type struct point and PTR2 will also point to data of type struct point. After this, I'm calling this function fun, and here I'm passing these two arguments 2 and 3. You can see the definition of this function. Here these two variables will receive these values. A will receive 2 and B will receive 3. We know that after calling the function, control will transfer from this point to this point. Now let's go along with the flow. Here let's consider this fun function. Within this fun function, you can see this statement over here. I want you to focus on the statement very carefully. You might be wondering why I'm calling this malloc function. Malloc function is used to allocate memory at heap. Why we want to allocate memory at heap? You will understand that in a moment. But let me tell you, this is very important step. I am allocating here memory at heap. You can see over here the parameter that has been passed to this malloc is size of struct point. This means that I'm asking malloc to allocate the memory of size equivalent to the size of this struct point. You can see over here this is struct point which consists of two members x and y. I want the malloc to allocate memory of size equivalent to the size of struct point. After allocating the memory, malloc will return a pointer, right? And that pointer is basically a void pointer. But I need to typecast it to a correct type. That is why this typecasting is required here. Struct point star. Now what does it mean? Malloc is returning a void pointer, right? As the data we want to store in that memory is of type struct point. That is why the pointer must be typecasted to struct point type. This is very important because that pointer will point to a struct point type of data which has been allocated at heap. That is why that pointer must be of type struct point. And here you can see the PTR will receive the address of the first byte of the memory, and obviously as it is pointing to a struct point type of data, that is why its type must be struct point. So this step is very important. You can understand that what is our requirement and why we are typecasting it in this way. Now let's see the second step over here. This is PTR arrow operator x equal to a, and this is PTR arrow operator y equals to b plus 5. Now this is interesting. Here, with the help of PTR, we are calling the members of this struct point. We can do that because PTR is the pointer which can point to struct point type of data. So here we can see struct point consists of two members x and y, and with the help of arrow operator, we can access these members very easily by using this PTR pointer. And here what we are trying to store the values stored in these variables a and b. A contains 2 and b contains 3. That is the initial case, right? We are calling this fun function. We are passing 2 and 3 to it. So obviously a contains 2 and b contains 3. 2 has been passed to x and 3 plus 5 has been passed to y, which means that after these two steps, x contains 2 and y contains 8. As simple as that. Here you can clearly see this time the values has been stored in the heap, right? Because PTR is a pointer which is pointing to a heap memory and not a stack memory. So it should be very clear that here we are passing the values to the heap memory. And what I am doing here, I am returning the pointer. And you can see over here the return type is also struct point star, right? Obviously we are returning a pointer of type struct point, so it should be struct point star. Now this is the point where we should understand why this malloc function has been called, why we are allocating memory at heap. Here we are returning a pointer, right? The simple justification that why I am using malloc over here is that heap memory is fixed. As simple as that. The memory allocated at heap remains fixed. We have to explicitly deallocate it. Remember that? Stack memory automatically get deallocated, but heap memory will not. It will remain intact. So the memory allocated at heap will remain as it is, and that is why we can easily return the address of the first byte of that memory without any problem, because that memory is fixed, and even after the function finishes its execution, the memory remains intact. It will remain in its place. Okay, that is why it is very important to allocate memory at heap. You should understand the end goal. We want to return a pointer, which means we want to return the address of some memory. We know that the stack memory automatically get deallocated. We can understand that these two variables get automatically deleted after the function finishes its execution because these two variables are local to this function. They have been allocated stack memory. When the function finishes its execution, these variables get automatically deleted. This is the reason why we have to use the heap memory, because we want to return the pointer. In that case, the memory should remain intact, and this is not possible with stack memory. That is why we are taking the help of heap memory. After returning the address, this address will get stored within this PTR1. Now you can understand that PTR1 also has the capability to access these variables x and y. Note the data type of this PTR1. It is struct point star. You can understand that PTR1 can also access these members x and y, which contains value 2 and 8. So here PTR1 is nothing but pointing to a heap memory which contains two values 2 and 8, and they are the values of x and y. Now, after this, we are calling fun function again, and this time we are passing different values to these variables a and b. There's no problem at all. A new memory has been allocated by malloc, and here in these x and y variables, we will store 6 and 9 plus 5, which is 14 respectively. And after that, we can simply return the address, and that address will be stored within this PTR2. Now the PTR2 is capable of accessing the variables x and y, which contains the values 6 and 14. And you can see over here, I'm calling this print function, and here I'm passing PTR1. And within this print function, we are calling a printf function, and we are accessing the values of x and y. You know the values of x and y. These values are 2 and 8 because we are passing PTR1 and not PTR2. So the output in this case will be 2 and 8. Again, we are calling print function, and this time we are passing PTR2, and we know the values of x and y associated with PTR2. They are 6 and 14. And after that, you can clearly see I'm calling this free function, which means I am deallocating the memory. That is why I'm saying when we allocate memory at heap, it is our responsibility to deallocate the memory. So the output of this program is obviously 2, 8, 6 and 14, right? Okay friends, this is it for now. Thank you for watching this presentation.
Okay, so based on the video presentation, no, again, returning a pointer, no, to a structure from a function is another common technique, no, in programming. And this method is used, often used, no, when you want to create a new structure within a function and return a pointer to it, or when you want to modify the content of a structure within a function and return a pointer, no, to the modified structure. So returning a pointer to a structure from a function is useful when you want to create a new structure within a function and return a pointer to it, or when you want to modify the content of a structure within a function and return pointer to the modified structure. However, it is important to remember to free the memory allocated for the structure when it is no longer needed to avoid memory leaks. No? So, the next one will be the passing arrays of a structure as an argument. So, in programming, passing an array or array of structures as an argument to a function is a common technique used to manipulate and process multiple structure in a program. And this method allows us to perform operations on all elements of the array with the function and to modify the elements of the array as needed. So, to pass an array, no, of structures as an argument to a function, you first declare the functions to accept an array of structures of the appropriate type or as an argument. Let's say, for example, no, struct space person, open begin, no, car space name, din yung curly bracket 50, closing ng curly bracket semicolon, then yung ating variable declaration pa rin na int age semicolon end semicolon. Then we can declare a function that accept an array of person structure like void space print underscore people, open parenthesis struct, no, person space person people, then tapos yung ating open and close bracket, no, then comma int, then space size close parenthesis begin. So this time gagamit na tayo ng looping. Let's say for open parenthesis in space I is equal to 0, semicolon, I is less than size, semicolon, I increment or yung plus close parenthesis din begin. Then of course, yung ating statement, print printf no, open parenthesis, double quotation, yung name, colon, no? Syempre yung ampersand natin na s, no? Yung percent s rather, comma din age, colon, then syempre pag age sinabi natin number, so percent d, backslash and double quotation begin, people, tapos yung I ipapasok natin doon sa sa dalawang curly bracket, no? Sa curly braces pala, sa brace lang, then name, comma, people, I ulit yung brace natin, then that age, close parenthesis, semicolon, dalawang n kasi nagbigin tayo para doon sa looping, nagbigin tayo para doon sa mismong void print people na function natin. So, in this example, no, print people or print underscore people function accept an array of person structure in the size of an array as arguments. So, the functions no uses a for loop, no, ang ginamit natin to iterate over each element of the array and print the name in age member for each person structure. So to call the print underscore people function with an array of person structures, we pass the array name and size as argument. Let's say for example, struct space person space people, lagyan natin ng 3, yung kanina 0 natin, na bracket or braces, na braces equal yung curly bracket na dalawa para do sa ating sa content, no? Let's say for example, lalagyan natin ng yung array, lagyan natin ng Marmelo Abante, comma 25, comma then syempre close bracket 'yun, curly bracket, no? Then comma, open bracket ulit, curly bracket ulit, double quotation ulit. Halimbawa naman ay Josie, Joan, no, comma, then 30 halimbawa, then comma, then open curly bracket ulit. Halimbawa naman Scotty Thompson, no, comma, tas 40, dalawang close pa na curly bracket, then semicolon. So therefore, after that, print underscore people, then open parenthesis people, comma, 3, close parenthesis, semicolon. In that example, we create an array of person structure called people with 3 elements and initialize each element with a name and age. So we then call the print underscore people functions with the people array and the size of an array which prints the name and age of each person is structured in the array. So I just want to show you a presentations, no, about what I have mentioned earlier.
Let's discuss part 6 of structures and functions.
In the previous presentation, we have learned how to return a pointer to a structure from the function. Now in this presentation, we will learn how to pass array of structures as argument. So without any delay, let's get started. Here you can see that I have declared one structure, struct ABC, which consists of 2 members, A and B. Data type of A is int, which means it's an integer variable, and data type of B is char, which means this is a character variable. Now here I have declared one array which consists of 2 elements, and the data type of these 2 elements is struct ABC. Okay, so this means that I have declared an array of structures, right? To be precise, this is an array of 2 structures. And here you can see these 2 structures. Okay, you can think of them as variables of type struct ABC. Okay, these 2 are variables of type struct ABC. Obviously, they are combined together, forming up an array. So here, this variable, I'm imagining this as a variable. This variable is of type struct ABC, which means that it can access the members of this struct ABC. And here, with the help of this variable, I'm initializing these members. That means 1 has been given to A and capital A, this letter has been given to this variable P. Now here, I have another variable which does the job of initializing these members as well. 2 has been given to A and capital B has been given to this variable B, right? Now here is one important point I would like to emphasize on. Compiler will allocate contiguous block of memory for the data members of the structure. It should be well noted that compiler will allocate contiguous block of memory. Okay, it is not the case it is allocating memory anywhere it wants. It's basically allocating contiguous block of memory for the data members of the structure. If you have any confusion regarding how the compiler will allocate memory for struct ABC, you should watch our lectures of C programming. There everything will be clear. Okay. Now here I'm considering one simple example. Here in this main function, I have declared an array of type struct point. That means tell you that this is an array which consists of two elements and each element is having a type struct point. And here you can see the initialization has been done. This is the struct point declaration which consists of two members x and y. Both are having the same type, that is int, which means that these are the two integer variables and here I'm initializing them one by one. This is the first variable and this is the second variable. Think of them as variables only if you have any confusion. Now this first variable is initializing these members with these values and this variable is initializing these members with these values, right? After that, I'm simply calling this print function and here I'm passing this array, complete array. When you're passing the name of the array, actually you're passing the address of that array, right? And here I'm receiving this array over here, right? This is the print function definition, which is receiving the array. Obviously, the type of this array must be struct point. It should be well noted. Inside this print function, we have this for loop, which runs from 0 to 1. As this is I less than 2, so loop runs from 0 to 1, which means this loop runs 2 times. And with the help of printf function, we are basically printing the values of x and y of each of these variables. When I is 0, we are basically calling our first variable and we are accessing the members of this variable. That is, here this is arr0.x, which means we are accessing this value, that is 1, and arr0.y, which means we are accessing this value 2. Similarly, when this becomes 1, then this is arr1.x, which means we are accessing this value 3. And when this is arr1.y, we are accessing this value 4. That's it. In this way, we would be able to print all the values on the screen and the output must be 1, 2, 3, 4. This is how this program works. It's very simple. Here, this array is of no difference, let me tell you. The only difference is that this array consists of two elements of type struct point, which we haven't seen before, right? We have seen array of integers, characters, floats, but we haven't seen something like this before. And there is no difference, let me tell you. You have created an array of two structures in this case. That is the only difference. It is just like declaring an array of two integers. As simple as that. You can easily call the members of this array. If you use arr0, it means that you're calling the first member of this array. That means the first structure. When this is arr1, you're calling the second structure. As simple as that. Treat them as individual members, okay? And then you can go inside and access the members. As it is indicated over here, when I put here .x, it means that I'm calling the first member of the first structure. Obviously, I must be 0 in this case. arr0 means that you're calling the first structure and .x means you're accessing the first member of the first structure, which means this member, right? Because x is the first member of the structure and y is the second member of the structure. So this is very simple to understand. Okay, friends. This is it for now.
Okay. So, passing an array of structures as an argument to a function is a powerful technique, no, that allow us to manipulate and process multiple structures in a program. So it can help to make our code more modular and easier to read and maintain. So the last topic that we're going to discuss for today is about a self-referential structure. So self-referential structures, also known as recursive structures or linked structures, are structures that contain a pointer to another structure of the same type. Kasi a while ago, we just name as a character, then age as an integer. So, this structure are commonly used to create linked data structures such as linked lists, trees, and graphs. To define a self-referential structure, you declare a structure type that contains a pointer to the same type of structure. Let's say, for example, no, I'll just give you an example of a self-referential structure definition for a binary tree. No, so let's say, for example, struct space node open or begin, no, int space data semicolon, then struct space node asterisk left semicolon, yung asterisk left as our pointer ulit, struct node asterisk right semicolon, then end semicolon. In the given example, no, the node structures contains an integer data, no? Or member, no? As well as two pointers, yung left and right, that point to node structures. And this pointer allow us to create a binary tree where its node in the tree contains a pointer to its left and right child nodes. So to create a new node in binary tree, we allocate memory for a new node structure using malloc and set its data left and right members as needed. Let's say, for example, struct space node, then space asterisk new underscore node is equal to malloc, open parenthesis, size of, open parenthesis, struct space node, dalawang double parenthesis, dalawang close parenthesis, no, semicolon. So new space node, tapos syempre yung arrow natin, data is equal to 10, semicolon. Then new underscore node, yung arrow, left is equal to null, semicolon. Then new node, arrow ulit, right naman is equal to null, semicolon. In this given example, no, we allocate memory for a new node structure and initialize its data left and right, no, members. So I just want to show you a presentation again.
Let's discuss part 7 of structures.
Functions. In the previous presentation, we have learned how to pass array of structures as argument. Now in this presentation, we will learn what are self-referential structures. So let's get started. The definition of self-referential structure is very simple. Self-referential structures are those structures in which one or more pointers points to the structure of the same type. This is the simple definition. And here you can see this is an example. Struct self is the structure which consists of two members. One is an integer variable p and the other one is a struct self star ptr. This is the pointer to the struct self itself. You can see that is why it is called self-referential structure, because here we have one or more pointers pointing to the structure of the same type. So this pointer is pointing to the structure of same type, that is struct self. That is why the structure is called self-referential structure. Here we have a pointer which is pointing to the struct self itself. Now let's consider one example. Here I have declared a struct code which consists of these three members. One is an integer variable I, the other one is a character variable C, and then we have a pointer which is pointing to struct code itself. Now in the main function, I have declared a struct code var1. Basically this is a variable of type struct code. As we know, this is a variable of type struct code, so it can access all these members without any problem. So here you can see var1 is accessing these members one by one. First, it is accessing this variable I and is initializing this variable by this value, that is 65. After that, it is accessing this member C and initializing this variable by this character A. And then it is accessing this pointer ptr and initializing this pointer with null. Initially, this is the case. Variable var1 is accessing this pointer ptr, which is a pointer to struct code itself, but at the end of the day, it is a pointer. It contains the address, right? Initially, it is containing null. Now, let's visualize how var1 will look like. Now, this is the visualization of a structure which consists of three members, right? var1 is a variable of type struct code. It consists of three members, and here is how this var1 is initializing the members. The first variable has been initialized with this value, the second variable has been initialized with this value, and as this is a pointer, so it has been initialized with this null. After this visualization, let's move on to our code again. Now here I have declared another variable of type struct code, and with the help of this variable I am initializing these members one by one with different values, of course. Here var2 is accessing variable I and is initializing this variable with value 66, right? And the rest of the members have also been initialized here. You can also visualize this in this way. This is how var2 looks like. Now let us suppose that the initial addresses or the starting addresses or the base addresses of these two structures are 1000 and 2000. This is my assumption, of course, and it could be anything. I'm assuming that these are my starting addresses. Now, here in this code, I have added one more line. I want you to focus on this line. This is var1.ptr equal to ampersand var2. Previously, var1.ptr has been initialized with null. Now here with this step, I am giving the address of var2 to var1.ptr. So what does it really mean? var1.ptr will now contain the address of the var2. We know the base address of this var2 is 2000, so it will contain this address 2000 here. As it is indicated that var1.ptr equals to ampersand of var2, which means that I'm asking the address of var2 and I'm storing this address here in this var1.ptr. That's why I have stored this address over here. After storing this address, of course, we can access this var2 easily with the help of var1 as well, because var1 has an address 2000, which is the address of var2. This means that var1 has the capability to access var2. So I have represented this relationship with this arrow over here. This means that var1 can access var2 members as well. The printf function, with the help of var1, I am trying to access the members of var2. Here you can see I have written var1.ptr, which means I am calling var2, right? Because var1.ptr contains the address of var2. So I am basically calling var2 and I am trying to access the member I of var2. And here you can see I'm accessing the member C of var2. This is very important point, let me tell you. With the help of var1, I'm trying to access the members of var2. Obviously, this arrow operator is required because this is a pointer. With the help of this arrow operator, I can directly access the members of var2, right? Here you can see I'm accessing the member I of var2 and here I'm accessing member C of var2. So the output of this program is 66B. You can understand that I have declared two variables of type struct code. With the help of first variable, I would be able to access the contents of the other variable as well. There is no problem at all. So why this is possible? Because here we have a struct code which consists of a pointer pointing to a struct code type of data only. That is why I have declared two variables of type struct code, and I have intentionally stored the address of var2 within var1 pointer. You can see over here that var1.ptr is containing the address of var2. This is possible because I have declared a pointer of type struct code. This is what self-referential structure is all about. Now, let's discuss how is it useful, how self-referential structures are useful. We will see the usefulness of self-referential structures in linked list. We will see how useful these self-referential structures are when we will discuss this topic, linked list. Okay friends, this is it for now. Thank you for watching this presentation.
Okay, so as I mentioned earlier, no, that is most commonly used with linked list, not only for linked list, but even for trees and graphs at the same time, no, and self-referential structure are powerful tools for creating complex data structures in programming. So by allowing a structure to contain a pointer to another structure of the same type, we can create dynamic linked data structures that can be easily manipulated and processed in a program. We need to understand that linked lists, trees and graphs are all examples of data structure that can be implemented using self-referential structure. And each of this data structure has its own unique properties in application and programming. In a sense that linked list is a data structure that consists of sequence of nodes where each nodes contain a data element and a pointer to the next node in the sequence. Linked lists can be implemented using a self-referential structure where each node contains a pointer to the next node in the list. Linked lists are commonly used in computer science, IT, for applications such as implementing stacks, keys, or queues na tinatawag natin, and hash tables. On the other hand, in addition, a tree is a data structure that consists of hierarchical set of nodes where each node has a parent node in zero and more child nodes. Tree can be implemented using a self-referential structure where each node contains pointers to its parent and child nodes. And trees are commonly used in IT or IT educations for applications such as, or computer science, such as file system, decision trees, and search algorithm. And moreover, a graph is a data structure that consists a set of vertices, no, and the and a set of edges that connect the vertices. No, graphs can be implemented using a self-referential structure where each vertex contains a list edges that connect it to other vertices. So graphics are commonly used in computer science, in IT for applications such as social networks, network routing algorithms, and even data mining. We need to take note that all this data structure can be implemented using self-referential structure and are important tools for solving a wide range of problems in IT or computer science. And by understanding the properties and applications of these data structures, programmers can choose the best data structure for the specific application and optimize the program for efficiency and scalability. So to end our discussion for tonight, no, I'll just want to reiterate once again that structure and functions are fundamental concepts in data structure that are used in organized and modularized code. No, structures again are data types that allow programmers to group related data together into a single entry. Structures can contain various data types, no, including other structure, and can be used to represent complex data structures such as linked lists, trees, and graphs, as what we discussed. So functions are blocks of code that perform specific tasks and can be reused throughout a program. No, sanay na tayo gumamit ng functions, especially sa Java. No, yung tinatawag lang natin, kinocall natin yung isang application. Let's say for example, yung computation halimbawa ng isang program, i-call lang natin yung automatic yon, no? Then functions take input arguments and can return output values, no, making them an essential tool for writing modular and efficient code. Again, structure and functions are work together to create efficient and modular programs. So structures can be passed as argument to functions, allowing functions to operate on complex data structure, and function can return structure or pointers to structures, allowing them to create and modify data structures. Overall, understanding how to use structure and functions effectively is very essential for writing efficient, modular, and maintainable code in our field. Okay, so I think that's it for today.